Welcome to this video on C# unit testing. This video assumes that you are coming into unit testing fresh. Maybe you don't know anything about the concept of software unit testing, and we're going to kind of dive into this as an introductory topic. This is one of those skills that separates a developer who writes code from a developer who writes quality code, code that lasts. So by the end of this video, you'll understand why this testing exists, what the different types of tests are, and most importantly, you'll know how to write your first unit test in C# using a pattern called arrange, act, and assert. I encourage you to have the reading material that's provided alongside this video. The slides and reading reinforce each other, and you'll get more out of it that way. So let me paint you a picture. You spend 2 days working on a feature, and it works perfectly on your machine, and you ship it. And then 20 minutes later, your phone is blowing up because 3 other features are now broken. And this is a real thing that happens, and it happens because of untested code. Testing is our safety net. It helps us write code and not break existing features that were already working. Since a lot of the pieces of our projects start to touch and interact, we need to make sure that we're not breaking working items to create new features. So, what are the 6 reasons ultimately why it matters? 1, we want to ensure quality. Tests are essentially a contract between your code and its expected behavior. If the test passes, the code does what it claims to do. It reduces cost. There's a well-known industry research that's been performed showing that fixing a bug in production can cost 6 times more than fixing it during development. In that developer time, QA time, business impact, testing moves that cost into the cheapest possible moment. It reduces risk. Untested code in production is essentially a liability. Edge cases that weren't thought about can cause data loss, security vulnerabilities, financial errors, and all kinds of problems. Tests force you to think through those scenarios before they can hit a real user. They facilitate changes. And this one is huge. When you have a solid suite of tests, you can refactor your code, you can make changes, you can add a new feature with confidence, knowing that if something breaks, a test will catch it immediately. Without tests, every change is essentially a gamble. And then we verify requirements. Tests can be written directly against those requirements that a client or a product owner gave you. If the test passes, we know the feature is done. That's a powerful way to build confidence and align your team. And that last point is about increasing confidence, not just for you as a developer, but for your QA, your quality people, for your manager, for the client. Confidence really is a deliverable, and tests are what produce it. So as a budding developer, as someone who's just getting started in this field, what you want to kind of embody is the idea that testing isn't about finding bugs, it's about preventing them from ever reaching the user in the first place. And it gives you essentially your green light. You know that you're done. You know the feature works. And you don't have to guess or worry that there's something you forgot to do. So think of this slide as a map of the testing landscape. There are 8 types of tests that we know and think about in software development. In this course, we're going to spend all of our time up in that top left corner thinking about unit tests. But it's important to understand the whole picture because you'll encounter all of these as you move through your coursework, become a more professional developer, and move into a professional environment. So unit tests are the smallest possible test. We're talking about one method, one behavior, one outside dependency, something that's fast and isolated, and really those are the kinds of tests you're going to learn to write in this course. Then there are different tests like integration tests. These are tests that look at two or more parts of a system and how they work together. So does your service layer call the database and get the right data back? Is a good example. Functional tests are when we want to test a complete user-facing feature. You're not testing just a small piece, but you're testing an outcome. Does login work? Does checkout work? End to end. System tests look at the entire application, and they're usually performed by a quality assurance team against an environment that has been deployed, so it's out in the environment already. End-to-end tests simulate real user behavior, typically in a browser or app environment. We can use tools that let us automate this so that we don't have to spend a lot of time clicking buttons and filling out forms. Regression tests, while are not entirely a separate type, it's more of a practice. Every time we change the code, we rerun all of our existing tests to make sure we didn't break anything. Performance tests, kind of right on the label. Load testing, stress testing, benchmarking. How does the system behave with 100 users? How does it behave with 100,000 users? We're testing performance to make sure the application works as expected. And then acceptance tests. This is where the product owner or the client validates that the software meets the agreed requirements. There are tools that can help us do this. So the key concept here is we are looking at the different types of tests, and you as a developer at this stage are not only going to get more proficient with your C# development, but you're going to learn how to write your own unit tests so that you can make sure that your code works as expected. So let's zoom in on those unit tests specifically. A unit test has 3 defining characteristics, and it runs in milliseconds, so super fast. It runs in complete isolation from everything else, and it produces the same result every single time you run it. If those properties aren't true, then it's not a unit test. So it has to be fast, isolated, repeatable, validates a single thing, and it can serve as documentation for your code. So isolation, this is where beginners often get tripped up. If the method or the function that we're testing calls a real database, our test is not isolated. Now in this course, you're not going to be working with any databases, but we will start to work with APIs that call databases. And so we do want to make kind of a difference here to make sure that we understand what a unit test is, so that when you get into building them yourself, you'll understand how it works. There are 3 popular frameworks for writing unit tests with C#. So MS Test is the one that ships with our Visual Studio software. It uses test classes and test methods, and that's the one that we're going to be working with in this course. If you're out there reading about unit tests, you may also run into InUnit, which is an older open source library for writing unit tests. It can be found in enterprise C# code bases, so you may run into this one kind of out in the wild once you're at a place where you're out looking for work. And then the newest of the 3 is xunit.net. And this one is kind of an increasingly default choice for new projects. It is more modern and what we call extensible, which means it can be built onto. Now, we're not going to get into too much of that yet. And from a usability standpoint, syntactically, they're not really that different. The underlying structure doesn't really change. And the idea on how we write a unit test really doesn't change. So, since we're talking about how do we write a unit test, we need to understand the most important structural pattern in unit testing. Now, if you've not encountered the phrase pattern before, a pattern is a framework inside of software development where we repeat a set of steps on a regular basis, or we repeat them under certain circumstances in order to get the expected outcome. And we find patterns throughout software development, and you learn patterns kind of outside of a language. So this is what makes it so easy for software developers to pick up one language and then quickly pick up a second. Patterns, structures, and concepts that you learn about software development don't really change. All you're picking up at that point is syntax. So the structural pattern in unit testing is called the arrange, act, assert pattern. And every test that you're going to write is going to follow it. And so arrange is the first kind of phase of this pattern. This is where you create any objects you're going to test, you set up any input values, you configure any things that you need to work with. It's the setting the stage before the curtain goes up, before the test needs to run. Everything it needs happens here in the arrange section. Then we act. This is where you call the one method you're testing, your one line of code, you capture the return value, you note a side effect, that's it. So we invoke the method or function being tested, we capture a return value or whatever our observable side effect is, and then we assert. This is where we verify that what happened is what we expected to have happen. If we use a framework, there are assertion methods like are equal, is true, is not null, and things like that. If the assertion fails, the test fails, and you get a clear message telling you exactly what went wrong. So the biggest beginner mistake is cramming multiple actions into the act phase, calling 3 methods in a row or something like that. We don't do that. One method per test. Remember, unit tests should be testing a very small thing. The second mistake is having like a dozen assert calls. If 10 assertions fail simultaneously, then you don't know which one is the actual problem. So we try to keep it focused and maybe only assert a few things or maybe just one thing. It is a great habit to start writing comments that say arrange, act, and assert right in your test method so that you can have that structure to follow and make sure, you're reading the right thing, at 11 p.m. when you have a debugging failure and your brain is mush. So let's look at a code example. So here is a MS test example of a quick method that we are looking at that tests a calculator function. So the first thing maybe you notice at the top of this is the annotation test class. So this is an attribute on how MS Test discovers test classes. There is a function inside of Visual Studio called a test runner, and it scans through your code, and it looks for classes marked with a test class attribute. Without it, none of the tests inside are going to run or show up in your test runner. The second annotation thing I want to point out here is the method name. This is public void add should return sum when given 2 numbers. So when we read it out loud, it reads like a sentence, right? The add method should return the sum when given 2 numbers. This is very clear, and if the test fails at like 3 a.m., anyone on the team knows exactly what broke without having to open any files. We always want these very descriptive type names when we're building our tests in our unit tests. So then we look at our arrange. We create a calculator object. We declare number 1 is 5 and number 2 is 7. So there's no database or file system or HTTP call or everything. It's very clean, right? And this is very beginner friendly. Should look really familiar from maybe your first intro to programming class. So we create something, we set 2 numbers. That's our arrange. Then our act is when we call our add function for the calculator and we pass it number 1 and number 2. The calculator add function, we understand to take 2 numbers and it adds them together and it returns a result. So in act, we're going to call the add, we're going to pass the 2 numbers, we're going to take the result. Then in our assert, we know if you take 5 and 7, you should get 12. We expect 12, and if add returns anything else, it's going to give us an exception and our test will fail. So our assertion R equal looks at the number 12 and the result variable. And if both of those are 12, R equal will return true, and we know that our test is correct. Now, it might seem, I think sometimes to beginners, you're a little bit like, why am I testing that 5 and 7 make 12? But what we're really testing is, does calculator.add, when given two numbers, add them together and produce a sum? It's a very simplistic type of a example, but with programming, a lot of times what we find is I can give you a very large real world example, but unfortunately at this point, I wouldn't expect you to understand it. So code you can understand is much better than code you can't, and it helps you understand the purpose of what we're trying to teach. Later, when your code is much more complex, it will become very apparent why we test the way that we do. So writing tests is one thing, and writing good tests is another. So here are some best practices about what a test really should have, and if you don't write good tests, they're going to just frustrate you 6 months later. So practice number 1, we name our tests very clearly. Method names should describe what is tested and what the expected outcome is. So our add should return sum when given two numbers. That is exactly the way that we want to name unit tests. Unit test names are essentially like documentation. 2, we keep tests independent. That means tests never share a session or a state or depend on their execution order. There's no prerequisites, right? So if test B only passes because test A ran first, you have a bad test. It's going to really bite you down the line. Test runners don't guarantee any kind of execution order, so every test needs to set up everything on its own in its setup, and it tears it all down at the end, and tests are independent. Practice 3, we test one thing at a time. Each test method should validate exactly one behavior, right? We sum two numbers, that's a behavior. We multiply two numbers, that's a behavior. We don't test add and multiply at the same time. So if you have 10 assertions in one file and it fails, you're going to spend 10 to 20 minutes trying to figure out which one actually caused it. So this is something to really think about if we go back to our example about summing two numbers. I asserted that they're equal. I didn't make any other assertions. I didn't assert that, one of them, or that both of them are numbers. I didn't assert that one of them isn't null, right? I didn't add a ton of assertions that I would have to check if one of them failed. So we have one clear behavior we're checking for. Is there a sum based on two numbers? And one clear failure message. If you need to assert a lot of different things, you might have a lot of unit tests that look very similar but assert different things, and that's fine. It's fine to have 5 unit tests all looking at one thing but assert a very different thing. The last thing is for later when we're looking at more complex code, but we want to use basically mocks or fake versions of databases, of data, and things like that. We don't want to test essentially on production environments. We don't want to test on live databases. It becomes very hard to actually differentiate your test data from your live data. So if number 4 doesn't make sense, we'll look at it again as we get into more complex code near the end of the semester. So inside of our Visual Studio, we can run our tests 2 different ways. We can open our Test Explorer by going up to the Test menu and opening Test Explorer, and then we can build our solution to discover tests, and we can run all and get a green check if they pass and a red X if they fail. Or if you like the command line, you can open the command line in Visual Studio and write .NET Test, and it will run them in the terminal, and it will show you if they pass or fail down there in the terminal. And what you really want to do is get in the habit, once you're building your tests and you're creating them, is to run them every time you make a change, before you commit. It takes seconds and it can save you a ton of time. And in the case of a class like this where I'm grading your work on, completion, like does it actually solve the problem we've set out to solve, then we want to look at, if your test doesn't pass, you're probably not going to get full credit. So a green check is going to give you a lot of peace of mind that you're getting a good grade. So let's bring it all together. And it can be tricky talking about testing with students of your level, which that's not derogatory, you're all learning. But tests can become a very complicated topic. Right now, we're just going to focus on the very small part of unit testing. Later, as you get into higher level classes, you'll write more of these types of tests that we've looked at. We'll start to get into some of this automated type testing, these CI/DI pipelines. Maybe you've heard that phrase before. If you take the DevOps class, you'll get into, how do these large scale cloud-based systems do testing? So testing, really, it's a core software engineering discipline. It's not optional. It's not extra credit. On any professional team, untested code is unfinished code. And as a new software developer, learning to write tests and learning to recognize, especially if you're starting to use AI tools, what a good test looks like is going to help you tons in just understanding code and whether or not your AI is lying to you. Unit tests should target a single method or a single thing in isolation. It's fast, it's repeatable, it has no external dependencies, right? Those prerequisites to run. Every test follows arrange, act, assert. We set it up, we invoke, we verify. There are these frameworks that we talked about. We're going to be using the MS test throughout the entire semester, but if you are reading about unit tests, if you're watching other YouTube videos and things like that, and they're talking about InUnit, XUnit, all these other tools, that's great. They're all valid choices. They will look different. So if you're looking at test code from other frameworks for testing, they're going to look different than our MS test code that we're looking at in class. Test names are documentation. We write them for the person who has to debug the failure at midnight and who's tired, which might be you. So always think about how we're naming our tests. And then tests run everywhere. They run in Visual Studio while you code. They run in the command line. Later, like I said, we get into these kind of higher level cloud-related tools so that we can run our tests on the more sophisticated software. So the next step from here, right, your assignment is to write your first unit tests. Take a look at the calculator example, look at your reading for some additional examples, and look at the lab instructions that will have specifics on what it is that you're writing. And remember, the best time to write a test is right before you code. And so a lot of people think I'll write the thing I'm going to test and then I'll write the test. But sometimes writing the test, at least a sketch of it, right? We just think about how we're going to test it, helps us write the code we actually want to test. So reach out with questions. Find me on Teams or email. If you're stuck, please let me know, and we'll keep moving along with our course. See you next time.